Hey everybody, Dr. Duncan here, continuing with our exploration of biodiversity. In this video lecture, we're going to look at deep time all the way to the current era, looking at changes in Earth's biodiversity. We're going to cover Earth's biodiversity patterns through deep time. We're going to look at the current mass extinction event and the causes of that event. You probably already know that we're in a period of severe declines in biodiversity. There's been lots of news about this in the past few years, but how does today's decline in biodiversity compare to changes in biodiversity throughout Earth's history? Let's take a look. To help us with an answer to this question, check out this graph illustrating marine biodiversity over the past 600 million years. Marine diversity is a good proxy for total biodiversity on Earth because fossils are found in sedimentary rocks. And as you know from an earlier class or video, sedimentary rocks arise from sediments deposited on the seafloor. Because we have lots of sedimentary rocks on the planet, we have a good way of looking back at changes in Earth's geology, climate, and biodiversity. In this figure, we can ignore the colors and the names of the taxa and the multiple lines. Just focus on the line at the very top, which represents the number of taxonomic families known from the fossil record through time. Most of these families include multiple genera and many species, so this is a relatively conservative way of graphing Earth's biodiversity. Now there's two things I want you to notice in this figure. Before I show them to you, see if you can figure them out for yourself. Pause the video and think about what patterns here may be important. Okay, the first thing I want you to notice is that the trend is for an increase in diversity over time. In general, the number of families increases as you approach the modern era. There are some biases in the fossil record that contribute to this, chiefly that more recent sedimentary rock preserves more fossils and better fossils than older rocks, and lots of the Earth's oldest rocks, including sedimentary rocks, have been destroyed through geologic processes. Nevertheless, there's enough data out there that this pattern is robust for showing an increase in biodiversity over time, which is exactly what you would expect as ancestral species split into two or more other species through allopatric and sympatric speciation. So in addition to an increase in species over time, the second thing I want you to notice in the figure is that there are periods when the diversity of species on the planet declines abruptly. Check out these red arrows. These are showing what happened to marine diversity during each of the 5 major declines. During these events, there were so many species lost that these events are referred to as mass extinctions. Remember that each family is representing many species, so these really were catastrophic events. Paleontologists and geologists believe that these mass extinction events have occurred for several reasons, that mostly involve the onset of ice ages, large asteroid impacts, and periods of intense volcanic activity. Sometimes there's strong evidence of what happened, but for several of the causes, it's not yet known. This includes the Permian extinction, which snuffed out over 90% of species on the planet, and it's a period known to geologists as the Great Dying. But what about today's extinction events? The data on biodiversity loss in our time is sending a clear signal that biodiversity is on the decline, here in the US and globally. This is a news report on a report that came out from a study that showed that humans have wiped out since 1970 about 60% of animal populations. That's not species, that's just raw number of animals across many different taxa. Here's another example of some news of late as we've gotten more statistics on biodiversity loss, and that is pointing out that we've wiped out 83% of wild mammals on the planet. So just looking at mammals, we're down to like 17% of what used to be on the planet in terms of mammal populations. And this one strikes really near to my heart. In North America, since about the time I was born, birds are down 29%. Again, this isn't species numbers that are down. This is the population sizes collectively of across all species are down 29% in North America over the past 50 years. Now, extinction is something that you might think about as being far away, like in tropical forests or in places like in developing countries and so forth. But in fact, there's been lots of extinctions right here at home in the southeast and right here in Alabama. As you see in the table, when you look at U.S. states for total species that have gone extinct, Alabama ranks number 2 at 90 species that have gone extinct. Now, if you consider the fact that species extinctions are exceptionally high around the world on islands, and that Hawaii is an island, then Alabama is in its own special category for being at the very top of U.S. states that are on the continent. And it's not that any other state actually comes close. California is has the second highest number of extinctions on the continental U.S., and they're at 53 extinctions. So Alabama has seen a disproportionate loss of species in its time. And there's a couple of reasons for that, and that involves how we have treated our rivers. As we have talked about before in a previous video lecture, we have a tremendous amount of aquatic biodiversity in the state of Alabama. And because we have been really hard on our river biodiversity over the past century, we've lost a lot of species, principally because of damming our rivers. And we've lost 2 to 3 fish species, over 30 species of freshwater snail, and 11 species of mussel. In addition to these, we've lost 4 species of mollusks that have been extirpated from the state but survive somewhere else. And this is just, of course, for the freshwater species. So the evidence is really strong that the rate of extinction in historical times is high enough to qualify the current period as one of mass extinction. It's estimated that it's about 1,000 times higher than the background rate before humans began to exert much pressure on the environment. And that's during historical times defined as being roughly since the year 1600. It's estimated that dozens of species go extinct each day, and that we're going to lose a lot of species by the end of this century, perhaps as much as 30 to 50% by some estimates. So this begs the question, have we triggered a 6th mass extinction? Now, it's important to realize that there are different definitions of what qualifies as a mass extinction event. Our textbook says that a mass extinction event means that you've lost 75% of species within 2 million years. However, different scientists use different thresholds for designating a period as a mass extinction event. The textbook hedges on whether the current era should be considered a mass extinction event, but there is very widespread agreement amongst scientists that we have triggered one, and it's the 6th mass extinction event for the planet, sometimes known as the Anthropocene extinction. So along those lines, this report came out in 2019. It's an international report from the world's leading experts in biodiversity, conservation science, and ecosystems. The data they present here are pretty grim. Of all the animal and plant species on Earth, and they use a very conservative total of about 8 million, they say up to 1 million of these species are threatened with extinction, many within decades. The extinction rate is 10 to hundreds of times higher compared to the average rate it's been over the last 10 million years, and that rate is accelerating. They estimate that 500,000 species have insufficient habitat currently for long-term survival. Estimates are that 40% of amphibians are threatened with extinction. Ditto for 33% of reef coral species and sharks. And they estimate that over 33% of marine mammals are facing extinction. The tally is that 680 vertebrate species have been driven to extinction by human actions since the 16th century. So why is this happening? Well, The ultimate causes to biodiversity loss are complex and involve issues of how we value other species and the degree to which we take actions to ensure a safe future for ourselves and the planet. We'll get to that soon. There are, however, 5 proximate causes for extinctions, and these are outlined in your textbook. Briefly, they include habitat loss and habitat degradation, the introduction of invasive exotic species, also known as non-native invasive species. These species have tremendously disruptive influences on the ecosystems in which they invade. A third reason is pollution, and this includes everything from oil spills to plastic trash to the chemicals used in manufacturing to having too much fertilizer wash off of agricultural areas during rainstorms. All of that leads to habitat degradation and in some cases has led to outright extinction. And another reason for the loss of many species is the overharvest of those species. Historically, that's been primarily for food, but we also have some cultural practices such as ivory carving and traditional medicines that value parts of different species, and that has led to many species getting very close to extinction, or in some cases actually being wiped out entirely. And then the final reason for why many species are threatened with extinction has to do with climate change, which is already pushing many threatened species even that much closer to the edge of extinction. We'll be talking more about climate change very soon. Altogether, the news on this is pretty grim. And to make matters worse, we have about 7.7 billion people on the planet right now, and we're going to be adding another 2 billion people by the year 2050. That's a lot of mouths to feed, and the push will be to convert the last wild places where biodiversity resides to push them towards agriculture to provide that food that we need. But that's just the bad news. What you don't hear about as much in the media is that the science of conservation biology is about 50 years old now, and there's an army of scholars, professionals, and volunteers who are out there every day finding and implementing solutions to pull species back from the brink of extinction. Our conservation knowledge is deep enough that I can confidently say that we have the knowledge for how to save most species. The barriers are not scientific, they are social. What will happen depends on 2 things: whether and how soon people change their consumption habits, and whether the world's governments will cooperate to develop and implement the policies and treaties needed to stop the loss of ecosystems and biodiversity. It is not too late, not by a long shot.